Hi, you guys. I just wanted to give you a little bit of help with your circles assignment that's on aleks. Some of the questions are a little bit tricky, so I'm going to do a few examples for you. I want you to write down everything that I'm writing down. I want you to follow along so that when you go to do your problems, you'll know how to do those. So first question is a word problem, and remember, whenever you're doing a word problem, the very first thing you want to do is read through the entire problem. Make sure that you know what the problem is about, and then you want to look for the question that you're supposed to answer. So here we go. A wheel on Elsa's bicycle is 2.5 feet in diameter. Elsa races the bicycle for 368 feet. How many times does the wheel turn as the bicycle travels this distance? So the question we're being asked, I underlined that in yellow. How many times does the wheel turn? So if the bicycle is, if she's racing for 368 feet, we want to know how many rotations of the wheel there are. That's basically what the question is asking us. So if I draw a bicycle wheel, and I know that the wheel has a diameter of 2.5 feet, okay? That's going to look like this. And when we think about a wheel, every time a wheel rotates one time. So let's say that we start here, the wheel rotates all the way around until we get back to the spot that we started at, okay? That is going to be circumference. So one rotation is equal to the distance of the circumference. That's how far it will travel in one rotation. So we want to know how many times does the wheel turn as the bicycle travels 368 feet. So we need to know how many feet it travels every one rotation. So we need to know circumference. So to find circumference, we use pi times diameter. It tells us to use 3.14 for pi, and then for the diameter, we know that that is 2.5 feet. So the circumference of this wheel, when I take the 3.14 and I multiply by 2.5, I'm going to get 7.85. So every time the wheel rotates once all the way around, it travels this many feet. Now that we know that, we can answer the question, which is how many times does the wheel turn as the bicycle travels this distance? Okay, so it travels this distance in one rotation. So we want to know how many rotations did the wheel make if the bicycle was being raced for 368 feet. So we take the 368, we're going to divide it by 7.85, because that's the amount for one. So 368 divided by 7.85, and that's going to give us 46.8789889. It gives us this big decimal. So now we need to look at our instructions, which say round your answer to the nearest tenth. So if I have this 46.8789, this is the tenths place. The number right after that is 5 or bigger. So the answer that you would type into aleks would be 46.9. So if you get a question like this on your aleks assignment, you just need to remember that one rotation of a wheel is circumference. Okay, if the wheel rotates one time, the circumference is how far that wheel travels in one rotation. Okay, next question. Find the area of a circle with a diameter of 12. Now, when we're finding area, remember our little saying, cherry pie's delicious and apple pies are too. So if we want to find area, we need radius. This tells us find the area of the circle with a diameter of 12, but we know if we want to find area, we need radius. But that's easy to find. If we want to find radius and we have diameter, remember I had you put your arms out. If you want radius, you've got to do half of that. So if your diameter is 12, that means your radius would be 6, right? It's going to be just half of that. So now we can plug into our formula for finding area. So area equals pi. So we're going to substitute 3.14. And then for the radius, we know that's 6. And so then remember, whenever we're doing this formula in our calculator, we have to follow order of operations. So we do 6 squared, which is not 12. 6 squared is 6 times 6. So that's 36. Then we are going to multiply that by 3.14. So when I do 36 times by 3.14, I get 113.04. And then with area, we have to do the units squared. So we're going to say centimeters squared. And then this was a 0. Okay. Next question. This one was, I feel like this one is a little bit tricky. You are going to have a couple of these just like this on your aleks assignment. So this one says, a flower garden is shaped like a circle. Its radius is 17 yards. A ring-shaped path goes around the garden. The width of the path is 5 yards. The gardener is going to cover the path with sand. If one bag of sand can cover 4 yards, how many bags of sand does the gardener need? Okay, so there's a lot going on in this problem. What you need to know is that basically you have a garden. This is the garden, right? It's a circle garden. And then all the way around that garden is a circle path. And the gardener wants to cover the path with sand. Okay, so he wants to cover just this part with sand. Okay, just this circle part with sand. He doesn't want to cover the garden with sand, just the circle pathway. Okay, so if we think about this, if the circle pathway is what we're going to need to cover in sand, we need to know the area of that circle pathway, right? So basically, we have this big circle that includes the path and the garden. And so if we subtract out the flower garden, what that's going to do is it's going to leave us with the area of the path. Okay, so we are going to need to know the area of the big circle. So that is everything, right? The area of the big circle. We are going to need to know the area of the small inner circle. And then we are going to subtract out the area of the small inner circle from the area of the big circle. And that's going to leave us with the area of the path. Okay, so here we go. To find the area of the big circle, we are going to need to use our area formula, which is area is equal to pi times radius squared. Now, for our big circle, we know that this radius of the small circle is 17, but then we also have an additional 5 yards for our path. So that means to find the area of the big circle, we're going to need to use the radius of 17 plus 5, which is going to be 22. Okay, so 22 squared times by pi, which is 3.14. So let's go ahead and do that one. 22 squared is 22 times 22. That's not 44. And then we're going to times by 3.14, which is 1,519.76. And then this is yards squared. Okay, so that's our whole big circle. Now we need to find the area of the smaller circle. So we're going to take our formula. Area is equal to pi times radius squared. This time we're only using the 17 because we're finding the area of the smaller circle, so we can subtract that out. So we're going to have 17 squared times by pi. So 17 squared is 17 times 17 times by pi, 3.14, and that gives us 907.46. Okay, so the area of my big circle, including the garden and the path, is 1,519.76. The area of the smaller inner circle is 907.46 yards squared. So if we want to know the area of just the path, we have to subtract those two. So when I subtract those two, I get 612.3 yards squared. Okay, now that we have this, we can answer our question of how many bags of sand does the gardener need. So one bag of sand can cover 4 yards, and if we need to cover this many yards, we need to know how many times 4 fits into 612.3. So we take the 612.3, we divide by 4, and that gives us 153.075 bags. Okay, and then it said the number of bags must be a whole number. So since we have this part, we're going to need to round this up to 144 bags of sand. Okay. Now for the last question, it says a triangle is placed in a semicircle with a radius of 8. Find the area of the shaded region. Okay, so we have a semicircle, right, which is half of a circle. We also have a triangle inside that semicircle, and so to be left with the area of the shaded region, basically we are going to have to take the area of the semicircle. We're going to have to subtract out the area of the triangle, and then what that's going to do is it's going to leave us with the area of this shaded space. Okay, so we know that a semicircle is half of a circle. So if we find the area of a full circle using our area formula, which is pi times radius squared, to find the area of a semicircle, once we get that, we'll just find half of it. Okay, so we're going to do 8 squared times by pi. So 8 squared, which is 64, times by pi, and that's for the full circle. So that's 200.96. That would be if this was a full circle, right? But because it's only half of a circle, we now need to take that number and divide by 2, which gives me 100.48. Okay, now for the triangle, you guys know that for the area of a triangle, it's 1/2 the base times the height. In this triangle, this is 8, this is 8. Okay, so the base is 16, right? If we're talking about a circle with a radius of 8, that means its diameter is 16, and that is the base of the triangle. Okay, so the base of your triangle is 16, and then the height of your triangle right here is 8. Okay, so let's do 1/2 times by the base times by the height. So 16 times by 8 times by 1/2 is 64. So now we have 100.48. We are going to minus the 64, and that gives us 36.48. That's the area of the shaded region that would be left if you take the area of the semicircle and you subtract out the area of the triangle. Okay, so if we take the area of this triangle and we subtract it out here from the area of the semicircle, we're going to be left with that shaded region. Okay, so now I hope that's helpful for you as you finish your ALEKS assignment. Remember that ALEKS assignment is homework due by the next time I see you.